Okay, guys. Good evening and thanks for joining. Sorry, I had a bit of technical challenge here, but finally I've managed to sort it out. So we can start. So as usual, please let me know whether you guys can, see my screen. Is it visible? And also if I'm audible before we start. Okay. Okay. I can see guys are confirming that yes, they're able to see my screen and also I'm audible enough. So that means we are set, we are good to go. So let's start. Now, yesterday, we were actually, discussing about OSPF, and we look at the OSPF and how it do operates and various ways, you can configure, the OSPF, huh? You can configure the OSPF. So, but, I did not, oh, sorry, I can see it's a hand up here. Okay, from Kevin. Sorry, Kevin.
Good afternoon, Geoffrey, and good afternoon, team. I hope you are doing well. Just maybe a second before you continue the class.
Sure.
First, commend the team for the consistency in attending the classes, and also to alert them just for accountability and tracking. We will share an attendance form. We'll share a link through the chat so that you can be able to fill your attendance. Sorry, we delayed in sharing the form, but hopefully you'll be able to be truthful enough and also be able to track the days that you have already attended. Thank you so much, Kitoto, for that. I just wanted to just clarify on that point. Thank you so much.
Thank you, Kevin. Okay, so guys, I was saying that, yesterday we were discussing about OSPF, its operation, and also how we can configure it. Now, because of time, we could not proceed with the configuration part of it. So that way, I decided that before, today, before starting another session, I first go through the lab part. Then after that, now we can proceed with other things. So sorry for that. So that's actually what I want us to start with. Now, when it's come to routing protocols, there are two categories of routing protocols here. We have, we have the static routing and dynamic routing. Static and dynamic. So when it comes to static routing, that is static manual routing, this is what we covered, if you remember. Okay, this is what we covered it somewhere in CCNA 2. Towards the end there, we talked about static routing and how it can be set up. In fact, the topology that you can see in front of you was set up using static routing. And we confirmed that this topology, or the devices within this topology, are able to communicate to each other using static. Static is good, but it is cumbersome, especially when you will be doing a complex network. You cannot do away with static completely. Still, even though yes, dynamic is okay, but at one point you need static, especially when setting up a default route. You can only do a default route using static, okay? When doing the mapping, okay, or where we have what I'm calling a stub network, that is a network with only one device or one path pointing to the other network. For example, the client and the ISP, the client and the ISP, that one we need, the default route, okay, to be set up there. Why default route? Because now, remember, you have the internal network or the private network and the public network. And of course, you'll be receiving traffic from outside, from outside. So the default route, this default route will be able, to accept all this, traffic that are coming in from outside. Okay, from outside, and you'll be able to receive all your messages as intended. That's why default static route is still being recommended. On the other side, or on other note, we need dynamic routing, especially when setting up our intra network. That is our internal networks, our branches, ICTA Nairobi, ICTA Mombasa, ICTA Kisumu, ICTA, we need to bring them together through a dynamic routing protocols. The likes of OSPF will be required and other dynamic routing protocols which are necessary. There are quite a number of dynamic routing protocols that, are being set up, including the OSPF, okay? Now, we have, link state, we sometimes, the categories, link state, protocols. So OSPF and ISIS, internetwork system to internetwork system, ISIS, are some of the link state protocols that we have. Why link states? Because remember what we said, that OSPF support packets, 5 major types of packets: the hello packet, okay, the reply packet, the query packet, the acknowledgement, all those packets, put them together, so that if you want to know more about me, then I'll just be sharing my packets with you, so that at least, okay, at least now we can have, how do you call it, now the details, okay, the link state advertisements, link state updates, and such now coming in, including the acknowledgement coming in. So that's why the OSPF, is very, very important, because other devices will be automatically, receive the update in case of any change within your topology. Okay, that's what will trigger the change. Whatever you want to do, the update that you have, in case maybe the new network that has been added, a network has been removed. So all other devices within the interior, okay, will be informed about the same, and they'll be able to either add or remove that particular network. So in that case, let's start by setting up this OSPF or configuring the OSPF. So if we look at this, we can just confirm our routers here. The first one, show IP route, okay, show IP route. So you can see here, we have static route that, was set up last time. Remember, these are remote networks which were set up, including the first one, the remote networks which were set up, if you can remember this one here, including the default route, which has been set up within R1, okay? So therefore, that means that, guys, our devices are able to communicate. If you remember last time we did this verification ping 192.168.2.10. You can also try 172.16.1.10 from this PC1. When you ping 192.168.2.10, okay, you'll find that our devices are communicating without any trouble, without any challenge, as you can see, okay, including 172.16.1.10. Okay. I hope we have that device on our network, or it's not there. It is there. Okay. That is the other PC. The other PC. Okay. So you can ping, you can trace that, trace that is a window command. So it will trace. You see, where is this device? Where is this device here? 172.16.1.10. Okay. The device is up here. It's PC2. Yeah, it's PC2. Okay. So it is tracing the route until it's locate that PC2. So if we check on that, so you'll find that the routes that you have successfully traversed are the ones that are being listed. Where is that? Sorry, PC. From the PC here. So which network is this? So you can see you have the default, the router interface, that is for R1, PC1 R1. So it means you are able to get into that. Okay. You have the 2.2. In this case, the interface of router 2, the serial interface of router 2, as you leave towards the PC2, also is being listed. So you have gone through it successfully. Then finally, your destination is there. So that is to say, it has listed this port here. This port is 3.1, this port here. Okay. So you have gone through this successfully. Then here, 2.2, the serial interface of R2 up here. So it means you have managed to access this R2 successfully until you get to your destination. So that is trace route. Now, for the other devices like routers and switches, but also you have set them up, you can either ping or still you can use a trace route, not trace data, to get into this. For example, let's try the interface of this is 192.168.2.1 here. Okay. Is that sorry? Trace 192.168 dot dot 2, just a minute, was it dot 2 here, this one, 2.1, correct. This interface here, G00 and 3G00 is what I want us to trace, so 2.1, okay. So you can see how how it has been traced complete. So trace that, okay. Trace route, that is, and trace that will actually be used mostly, to do this verification. Now, that means everything is okay. So let's start by now configuring. I'll not remove this. There's something that I want us to see here. I'll not remove the static. I'll just leave it. But take the note of the AD. Remember, it's AD metric. AD metric. You can see metric is 0. Okay, for this. The AD is 1. the administrative distance. The distance is 1 for static route. Metric is 0. Okay, so let's now configure the OSPF. Okay, the OSPF. Now remember what we said yesterday. You can configure the OSPF in 2 ways. You can use the network way, okay, and you can use the IP OSPF. IP OSPF. So IP OSPF mostly being required when now you are setting them on the interfaces. You are advertising the network, but on the interfaces, okay? But before then, you'll have to declare it on the global mode. IP OSPF 10 area 0, okay? You'll have to declare it on the global. Then now on the interfaces, now it will be accepted. But if you decide to go the other way around, the network way, then it's on the global mode, where you advertise now what you have, unlike the static where we were advertising what you don't have. Here, you advertise what you can see, what you have, okay? We also talked of quad 0 yesterday, 0.0.0.0 as the other part of the wildcard mask that you can use. For example, if you take the network, so this is what we meant. If I can take you back to the interface, you see, you want to advertise the network, but now on the interfaces, the interface G000, which is 172.16.3.1. The interface between R1 and R2, which is 172.16.2.1 here and 2.2 up here. So if you opt to use code 0, okay, it means now you don't look at the network, but the interfaces IP addresses, okay, 3.1, 2.1, and such. So that one, yes, you'll use those. This one is mostly recommended when you are doing a multi-area OSPF. Multi-area OSPF. We used to have single area OSPF and multi-area OSPF. So multi-area OSPF was removed. Within the curriculum, the CCNA curriculum, we don't have it. It is in CCNP. Okay, that's why actually now we can cover it in detail, CCNP. But here, single area OSPF is what we are doing here. But multi-area OSPF now is recommended, especially when now, the regions, your regions, coastal region, and maybe Nairobi region, you'll find that there's a common area that will be sharing. The interfaces will be sharing a common area. So that way, they recommend that, how do you call it? They recommend a code 0 to be used in such kind of cases. Okay, that's a CCNP story for the other time. Okay, let's go ahead and see now. So I'm going to have my two networks. Sorry, where are we? Okay, sorry, it is router. Sorry, router OSPF 10. Remember, the process ID that we talked about yesterday is in the range of 1 to which part? It is 1 all the way to 65,535. If you can remember, we talked about it yesterday. That's the range. So you can use any process ID in between 1 to 65,535. So for consistency, I'll be using 10, 10, 10, 10. Okay, that's what actually they advertise. I mean, they advise or they recommend. So network. So which networks do we have on R1? On R1, we have this network 172.16.3.0 and 172.16.2.0 for the case of IPv4. For the case of IPv4, okay? So you can have 172.16.2.0, okay, with a mask of 255. No, not subnet mask. It's a wildcard mask. Sorry, wildcard mask of. So how we calculate our wildcard mask. Huh? it is the subnet mask subtract from the default subnet mask, the broadcast 255.255.255.255, which gives you 0.0.0.255 area 0. That's the first network. The other network is 3. Okay, so these are the two networks that we have within R1. Then now R2, there are how many networks on R2? Are you able to see? Yes, let's remind ourselves. Last time we talked about them when we were doing this diagram. How many networks are directly attached on R2? How many? Is it 1? Is it 2? Is it 3? Is it 4? Is it 3? There's some manna, Moses. Yes, it is 3. Three networks. That is 172.16.2.0 is part of that router. 172.16.1.0 is part of it, and 192.168.1.0 is part of it. So all these must be advertised. Now, there is only one network that will now enable the adjacency. Remember what we talked about yesterday. What will make the adjacency to be formed? Okay, we talked about LO interval, dead interval, correct? We also said it must also belong to the same one, the same network. Okay, same network are there. Okay, guys, please mute. We also talk about the same network. So if you look at R1 and R2, they belong to the same network there. So here, for the adjacency to be formed between the two, router OSPF 10, okay, then network 172.16 .2.0, then 0.0.0.255 area 0. Okay, so this is common. It's a common network on R1 and R2. The moment you enter, you will see the adjacency being formed. You see this one, okay, and the state has changed from the loading to full state. Loading done. So this is an adjacency message that we are getting. So meaning, if you confirm, you'll find that now that network has been what? Advertised. Then we need to do the other network. So we have also talked of 1.0. Okay. And also this will not form the adjacency because we don't have 1.0 on our R1. Okay. Okay, even if it's there, it's not common. Then we have the other one. To refer again here, 192.168.1.0 apart from 16.1.0. So 192 also is there. Okay, that we need to. So I can just have this 192.168.1.0 as per what we have here. Okay, then you enter. Sorry, enter. So we have those three. We have those three networks advertised. Now, again, we expect adjacency to be formed, okay, between R2 and R3 because 1.0 or 192.168.1.0 is common on both. It is common on both. So yes, we go. Okay. Router. Okay. Router OSPF 10 network 192.168.1.0. Okay. Then okay, we are good to go. So then 0.0.0.255 area 0. So it's a common network on R1 and R2. So meaning they're on the same network. So one of the factors that we talked about for the additions to be formed is that the devices must be on the same network and they're on the same network. So we expect that adjacency to be created, and in a few, the app data, is supposed to be up, and that's where we are. Okay, adjacency, you can see are being formed there. Then now we can have the other one, because there are only two on this, 2.0. So if you check on that, yeah, 2.0 here. So if you check on that, guys, so you'll find that now we are done with this advertisement of the network using the network command. If you wish, you can also do the interface command, IPOSPF10 area 0, but on the interfaces, first on the global, then on each interface. So the same thing on each interface, G000 here, and serial 010 here, on all your serial interfaces, 3 of them, and all these 2 serial interfaces. Okay, now you can go ahead and confirm. Now that we have set it, let's see. I can end this, then show IP root. Now, what are we seeing? What are we seeing? Remember, we have configured the OSPF, but the OSPF is still floating because the routers does not trust it because of its AD. OSPF do have an AD of 110. Static has 1. In case you have multiple protocols being advertised on a routers, the one that will be installed is the one with the lowest AD. So in that case, static has the lowest AD 1. So it cannot allow the other one to come in. So the only way the other one can come in, okay, the only way the other one can come in is to remove the previous one. These ones here, where are they? This. You see here, this one. You see this? Okay. They are there, both IPv4 and IPv6. For the case of IPv4, up here, they are here. Okay. So we must remove them. Config T, then no, start with this. So no IP root. Okay. Copy, paste, enter. Okay. No, this second one or the third one. No, this. Okay. Copy, paste. Okay. No space. Okay. I will not remove the default because I still need it. We need default. Copy, paste. Okay. I've removed that. Then I'll move to R2. Okay. Exit. Okay. Do show run. So there were two. Remember, we said there were two that we set. Okay. Our adjacency, our OSPF is there. You see, it is here because you have set it. It is here. But it cannot be installed until we remove the static. So we also need to remove this. So copy this, then no paste. Okay. No paste the other one. Copy, paste. Okay. One more. R3. Exit. Exit. Then do show run. Why do? Because I'm on the wrong, not wrong, but the interface that does not support show run. Huh? So that's why do is coming in to enable it. Okay, to enable it there. Okay, so let's now no space. Okay, so which one is IPv? So there are three because of the other side of R1, R2. So we remove, so it's 1, 2, 3. This is what I'm calling contiguous network. They're from the same class and also they can be summarized. Contiguous network. Okay, paste. So this is 2, paste. And finally 3. Oh, sorry, not paste, but just to remove them, enter. Okay, so I've removed all this. So when you confirm, again, do show IP root. You'll find that OSPF now has been installed. So it means, guys, it's now serving as a backup. Just in case there might be a challenge with one protocol, the other one will be installed automatically. So it's always advisable, recommended, okay, to have, you can have this protocol, different protocols. I mean, different routing protocols like OSPF, like ERGRP, those are the ones being used, okay, here. So you can see now we have them being installed automatically. Okay, this is on R3. If you confirm R2, we expect the same thing. Do show IP root. Okay, it is here, O for OSPF. It is here, O for OSPF. Okay, automatically being now installed. If you check do show IP root, same thing on R1. Okay, they're all given there. Okay, now we have this static root also set up. Static root set up here for us. Now, sometimes you want this static route to appear on R2 and R3. You just configure it on R1, then that is it. You don't configure it on R2, you don't configure it on R3. So it will be propagated. So remember the command default information originate that we talked about yesterday? Yes, it's the one that now we need to apply here. Default information originate, okay, within the global mode. Default information originate, okay. Default interface. Default information sorry guys. First you move to router OSPF 10. Sorry, you have to get into this. Then default information originate. Sorry for that. Default information originate. Okay. Enter. When you enter, so go to R2 and R3 and confirm. Okay. R2, R3. Do show IP route. You'll find that a default route has been set up. Okay. But now appearing as external route, and see E, then 2. Okay. So this now appearing here as an external route, meaning it's something which has been, brought from outside. It was not set up here. But now, the beauty of having this default route in each and every router, just in case you receive a packet whose network is not within the routing table, it will be given, it will be channeled out. It will be directed to you, okay? Because it's a default route there. If you move to R3, okay, do show IP route, you'll find that it is still there, okay, as an external route there, okay, appearing there, because it was configured on R1, but it is an external route. So all packets which are foreign or whose addresses are not there also will be accepted. And that's how we normally receive, emails even from outside the country being allowed within our network because of these default routes that we have. Okay, so it can accept such kind. So meaning our devices will still communicate because the network was advertised there. Okay, if you ping, still the same thing. Okay, because you have advertised your network. So basically that's how the OSPF is supposed to be configured. So within the CCNA curriculum, it is OSPF. It is OSPF being set up. Now, how do you call it? Okay. Okay. Now the packets, okay, are very, very crucial for us here. Okay, if you check in each router, okay, show, do show IP route. Do show IP route. Okay, then is that not there's something here I want to confirm. Now look at this. Okay, the AD and the metric here, they are not the same. Why? Because of the routes that you have taken, because of the routes that we have taken there. So they will not be the same. By default, you'll find that the metric usually is 65 by default. That's what you usually get for the OSPF. But as you move out, you'll find that, okay, it keep on adding, okay, it keep on adding this. It keep on adding this, as those are metrics that that we have are there. So that's very, very crucial, guys, for us to understand there. Okay. Sure. Let me exit here. Show IP interface. Oh, sorry. Show IP OSPF interface. This one here. I was looking for this interface here. Do you have a specific interface? Yes. If you want to do G0/0/0. Okay. Now, if you check on that, timer intervals configured. Hello by default is 10. Dead is 40. Okay. Wait time 40. So this, the other factor that we need to consider here, okay, is this hello and dead interval. The adjacency has been formed because hello and dead interval is the same in all. Okay, is the same in all. If you check each of those routers, copy this R1, move to R2. Okay, each of those interfaces, bit serial or Ethernet based, you'll find they'll have the same. Okay, this now R2. You can see hello and dead. Okay, you can check also this one exit based. So the same thing, hello and dead is the same. Now, which type of OSPF network is this? Our topology is a multi-access network. We have types of OSPF network. We have point-to-point, and we have, multi-access or broadcast. Okay, so ours is broadcast, as you can see here. And R1, R2, R3, also the same thing, broadcast. So we expect that adjacency to be formed. The reason why I'm emphasizing this is because it's a common questions also do this, which normally come up in certification there. Okay. Did we set, guys, did we set the router ID? Did we set the router ID? No, we didn't set the router ID. Okay. So if you check, again, look at the DR and BDR, designated router and backup designated router. And we said, remember the four things that we talked about. Okay. The router ID, the loopback interfaces, the physical interfaces, there were three. Okay. That will be considered. So in case you have not configured the router ID manually, the system will generate one for you. And it will take the one with the highest router interface number to be the what? To be the DR. So if you look at this particular state where we are, the router ID for this, the highest interface ID on this router is 2.1. Okay. So state DR. Okay. So you can see no backup designated router on this network. Let's check this R3. Let's check R1. R1. Okay. On R1, you can see, look at state. Okay. DR. Again, no backup designated router on this network. Okay. So in that case, the ID that has been used here designated router ID, okay, is this one here. Look at now the other one. Was it R2? Yeah, R2. Okay. Designated, okay, is this. State, you see, why all this? Why all this? Okay. We have not set up anything. And you see, the priority is the same in each. Is the same in each. So we can go ahead and now force one to be the DR. If you go back to global mode, config T, this router 1, then router OSPF 10 with the router ID, with the router ID being 1.1.1.1. Okay, enter. Then you'll be told that reload or use clear IP OSPF command for this to take effect. Okay, so meaning we need now to go back, okay, to privilege mode and use this command here, reload. You can reload, reload, or you can just use the other one. Okay, system configuration has been modified. Save yes. Okay, so it will reload. So you can see it's red in color. So let's do the other one as well. Okay, config T, router OSPF 10. Okay, then router ID, this router 2.2.2.2. Okay, so it is here. Okay, it is there. Then you can see. So exit. So you can use the command clear IP OSPF process, or you can just have reload. Okay, to check on that. Yes. Let's do the same for the other one. This one is almost coming up, but because we have just reloaded this, so it will have to take time. Then let's do the other one as router OSPF 10. Then router ID, okay, is now 3.3.3.3. Okay, enter. Okay, enter. But again, exit, then reload. Yes. Okay. So expect that the other routers interfaces are supposed to be up. So except now this one, we wait for this to be up. So let's give it few seconds. It will be up in a few because we were just, okay, now it's coming up, turning green. Green. Okay. Now it is up. So when you go back and have the command show IP OSPF interface, okay, whether it's G00, or interface, you'll find that now it has changed. Designated router ID, yes, it has changed. It has changed here. Okay, this one is 1.1. Okay, this one Show IP interfaces. Show IP OSPF interfaces or interface. Okay. Again, you'll find that. Okay, you'll find that it has, where is it? Here. Where is this? Where is this? Where is this? Is it up? Router ID. Yeah, it is here. It has changed. Okay, it has changed here. Okay. Then finally the same thing here. You'll find that also this one has changed. So again, show IP OSPF, okay, interface. So then it has changed here, okay. So that's the most important bit that also we need to take note of. So if also check the protocols, which protocols is this? Show IP OSPF protocols. Show IP, sorry, show IP protocols. Sorry, show IP protocols. Okay, show IP protocol. Yes, so you'll be able to see that up here. Okay, you have that protocol being stated there. Okay, so that's the most important bit that we have there. So that's all about the OSPF bit which was remaining. So I'll just save this because I still need this. I can just write. There are various commands for saving. You can just write memory and it will be saved. Copy, running config, startup config to save, or you can just do write memory, okay, for your configurations. Anything new that you have added to be saved there, okay, write memory, and everything is saved. Now, at this juncture, allow me now to introduce the next bit. But still, I'll be using the same diagram. That diagram is still important for us, the topology, for the remaining chapters that we have. So we have the ACLs, access control lists. So remember, we talked about network security, okay, in CCNA 3, that is enterprise network security and automation. So now the security bit, the ACL. When you want to enhance your security within the network, password is just first line of defense, but you need more additional security within the network there. So this way, now we'll be able to filter what you want, what you don't want there. We'll be able to separate. So we'll be looking at two types of SCL. That is standard SCL and extended SCL. So we have both named and named and numbered. Named and numbered SCLs, access control list. So SCL, yes, can be created. But mostly remember, SCL will follow a sequential order. How you have specified it, how you have stated it. That's the most important bit that you need to understand. So you must plan for it. So when configuring a complex SCL, it is suggested that you use a text editor, things like Notepad, WordPad, Notepad, okay, text editor, and now write out the specific of the policy to be implemented. But we don't just configure this for the sake of it, or because you want to. It has to be documented within the policy, because otherwise, if we don't, then people can misuse it. Okay, that is, you can say, I don't want so and so. I hate this particular department, so I want to block them from accessing the servers. So you end up blocking the entire department or a specific individual from accessing your network, okay, using the SCLs. That's why actually it has to be documented, okay, within the policies. So you have to be guided there, and let the head know, the one in charge know that SCL is being set up within the network. So everybody knows that SCL exists there. So add the iOS configuration command to accomplish those tasks. You can use the remarks to document the SCL. That is, I want to know what this SCL does, okay? What this SCL does. So I need also to document it. The remark is very, very important. Yes, you can make use of copy and paste commands, of course, yes, okay? Instead of typing things here and there. So you can just have, those copy paste. Always thoroughly test an SCL to ensure that it is correctly applies the desired policy. So as you keep on configuring your SCL, please keep on testing it one at a time. And it is advisable not to do it during the working hours, the business, hours. Do it after. From this time onward, at night, because you will not be interfering with any business that is going on within your enterprise. Okay. So with SCL, how do you create the SCL? Okay, the SCL, as we have said, we have both standard and extended, and each have numbered or named. Okay, so to create a numbered standard SCL, use the access list command. This is a numbered standard SCL. Access list, then with the access list number. Then what do you want to do? Okay, so we have all those parameters being given here. Access list number, a number ranging from 1 to 99 or from 1300 to 1999. Okay, is a standard SCL number. Then do you want to deny? Do you want to permit? So deny access if the condition is matched. Permit access if the condition is matched, depending with what you are doing. Then the remark, even though it's optional, but always or sometimes is recommended, you have it. Okay, so that somebody will be able to know, how comes I'm not able to access this? So if someone is checking your configurations, you'll be able to see, oh, an ACL was configured here with a remark given, okay, block department B, block or allow department A, so that I know why I'm not accessing this place and this place. It is well or clearly stated within the SCL are there. Then the source. Identify the source network or host address to filter. Which one is that? Together with their wildcard mask. Okay, for that specific host are there. The log. Logs will be created or generated. Okay, so if you want the logs to be captured, you can also specify the log. In case of any, auditing of the network, the logs will clearly state. So this one generates and sends an informational message when the SCL entry is matched. The entry is matched. So we know if I get to the logs, if you get the logs, I'll be able to understand the logs that actually will be generated are there. The logs that will be generated, and more so within the server. Allow me to add something here additional. The server, I want to put the server somewhere. Any of the Ethernet interface, then. So this one was 2 what? Oh, this one was 3.10. I can even put this one 3.11. So 2.16.3.11. Okay. Remember it's 24, prefix 24. So I have 255 there. Then there was a default gateway, of course, that was set. 3.1. So default gateway is there. Okay. So I can just ping to find out that this one also is reachable. It's reachable 3.11 are there. It's also reachable. It's within your network. So some of the services that you want to enable within the server, in case the logs also have been generated services, so you can just set the syslog and put the syslog on. So all of them, okay, will be appearing here. But on that interface, logging must be enabled. Logging must be enabled, meaning you have to go to the interface and you set the IP address of this, which was 3.1. So you can set the logging on that interface config T. Okay, interface G0/0/0. Okay, then you do your logging. The logging, usually it's just a minute. How come it's not being accepted? Or this interface, let me check. Just a minute. Logging. No, it has to be. Let me see. Okay, let me check. It is supposed to be in the global mode. Okay, logging. Yeah, logging. Then log. Sorry. Then you specify set syslog server IP address are there. That is 172.16.3.1. Okay, so meaning it will be capturing all those loggings that are there, including the one for the OS, the one for the what, the SCLs that has been set. So in case of anything, if the interface may be here, you have opted this interface to be shut down. Okay, then to be enabled. So these are just kind of notification that is supposed to be captured within the logs. Let me see whether it can. Oh, I need to close this. Okay. It's taking time to. Okay. Let's give it time. I know. Let's give it time. I'll be able to see. We'll be able to see the kind of notifications that we'll be getting here. Let's give it time. I'll try it later. So let's just proceed with this, and also we'll be able to set these logs so that all the logs will be captured there. Okay. Okay. So now that one was numbered. It was numbered as standard SCL. We have also named. What's the difference between the two? Okay. To create a named standard SCL, the command is IP access list standard. IP access list standard. To create a numbered standard SCL, the command is access list. Access list. Named SCL usually start with the word IP. IP, take note of that. IP. IP access list, then standard. The other one is just access list. Access list. So I hope you can see the difference. Okay. This one is a common also lab within the certification. No? The SCL labs usually is there. You'll get one SCL lab that they want you to configure are there. So SCL names are alphanumeric. Alphanumeric, case sensitive, and must be unique. Okay. Case sensitive and must be unique. That is SCL names. Okay. That we'll be configuring there. Capitalizing SCL names is not required, but makes them stand out when viewing the what? The running config output. So it's good to capitalize that. Okay. Capitalizing is important as well. Then don't forget your interfaces. Don't forget your interfaces. You give the direction how this will be moving. So after a standard SCL is configured, you must link to an interface there using the command IP access group. In, out. What is the direction? So what is the flow of the traffic? What is the flow of the traffic? Here, okay? Assuming it's PC1 accessing PC3, okay? So traffic is coming in here on this interface. So in, then out, in, out, here, in, out, here, in, out. That is the direction. In, out will be your direction, depending on the interface where you are configuring that SCL. So in, out, in, out, in, out. You must give the right directions. Otherwise, you might end up blocking people, okay, because you have given the wrong word, direction. So to remove any SCL configured within the interface, the command is no IP access group. Okay, just remove it from the interfaces. So you can remove the SCL from the global mode, but you have not removed it from the interface. So you can remove it from the global mode, then get in the interface, also remove it from the interface, and there. Okay, so the examples of the numbered standard SCL. Look at this, what they have set up here. This is unnumbered. So the example SCL permits traffic from host 192.168.10.10 and all hosts on this network 192.168.20.0. So this is a specific individual host, but this one is the network, meaning all the hosts, all the computers within this network, okay, also will be affected in one way or the other. So when you said access list 10, look at your remark. Remark, okay, what is your remark? Access control entries permits only host. This is a remark you are giving. Huh? It's a remark you are giving. So as somebody will be able to know what you're configuring. So it permits only host 192.168.10.10 to the internet. Even though it's optional, but it's being recommended you put it so that I'm not here today. Tomorrow, where you are, someone will be there tomorrow. Because I cannot access you or I cannot reach out to you through your remarks that you have provided or the descriptions, because we have those descriptions also as well. It will guide someone to understand how your network is operating. So access list 10 permit host. So this one you are permitting one host, okay? So this one is permitted, this host is permitted here, okay? Then, if you look at the second one, the remark, this one here, .20 or 20.0 here, okay? Access list 10, remark, this entry permits all hosts in LAN 2, all hosts, unlike the first one. The former is just one host. Assuming that network of 192.168.10.0, only one host is permitted, the rest denied, okay? So then access list 10 permit, see, all hosts in this network are allowed, So if you confirm that, you'll find that, yes, you have it here being added here. So you have the sequence numbers that are automatically being created like 10, 20, which are very, very, again, important for us, especially when you want to modify your network. If I want to remove that access list, I'll not type everything. I can just say no 10. It will be able to understand what you want to remove. So it will remove the entire statement of permit 192.168.10.10 or no 20. It will remove the other one. Okay. Then the interfaces, as you have said, you need to check your interface. Interface serial 010, IP access group 10 out. 10 out. So assuming here, okay, assuming here, you have set the SCL on R3, okay, and you see it is PC3. So direction here will be out, G000 out. If it's a must, you configure it on the serial interface here, serial 011, then it will be in, because you are getting in, then out. If it's a must, you configure it on this serial, then it has to be in, not out. In, traffic is getting in, moving from left to right or right to left. So it is you to check your network, the flow of traffic. Is it from left to right, right to left? Okay, that will help you determine the direction of your what? Of your network there. Okay. Then when you verify that, show running config or show IP interface, you'll be able to see that, yes, the ACL has been configured. Show run, because I don't want everything. I want only traffic which are related to SCL, so I can filter with a pipe character section, okay, that vertical line, then section access list. Give me only that. The keywords, if you remember, was it in CCNA 1 or CCNA 2? These keywords, section, include, exclude, are the terminology that we'll be using whenever filtering the traffic, So it will give you what you have requested, because with the showrunner alone, you have the entire output being displayed. But I'm not interested with all those. I want just to analyze the SCL traffic, how they have been configured there. You can do the same on the interface. Show IP interface serial 010. Include access list on that interface. So it will give you what has been set. Outgoing access list. So out, direction was out, okay, are there. For the named standard SCL, again, access list 10, okay. IP access list, they have removed the first one, the standard one, the numbered one, sorry. They have the named IP access list standard permit access. That's the command. But you can see with this one, unlike the numbered, where everything will be within one line, including your remark. Where was it? Here, including your remark. This one, now the named, now you'll do them separately. Remark separately, you can see remark on its own line, then permit again. So remark this entry, access control entries, permit host this. Then which host we were permitted? This one. Okay, this one. So this is the order this particular traffic or packet will be processed in the order in which you have specified. So sometimes, sometimes people make mistakes with the SELs. Huh? You say deny. Okay, deny. Imagine you are denying the entire network. You're saying deny 192.168.10.0. That's the network you have blocked. Then below it, permit host 192.168.10.10. There will be no communication there because you see, already you have blocked the gateway, the network. And your host 10.10 is part of that network that you have blocked. So don't expect any communication to be through because you have blocked the entire traffic. Okay? Those kind of mistakes are common, are there. Okay? So in case you want to modify the SELs, as you have said, you can make use of the text editor as one of the method or sequence numbers that you have seen. The one that you have seen being automatically added. Okay. You saw 10, 20, this one. Okay. Yeah. Or you can just use the text editor. So in fact, it is recommended all your configurations within your network. It's good to copy paste them and save them in a document somewhere. Just in case of any eventuality, you have a backup somewhere. We can just copy paste them back. Unlike, you don't have any backup of your configurations that you have done somewhere. It will be stressful because it means you will start everything from the scratch. Okay, you don't want to go, that direction again because that way you'll have a long night. Okay, trying to do a new configurations there. So make use of that. Now, with the text editor method, as we have said, we're actually having this text editor. So you can easily modify, okay, or edit those commands. Let's say they are more or less the same with what you want to paste on R2, router 2, or router 3. So why again do again from the scratch? And you have it on R1. So take time, do R1 properly, then copy paste them, then now do a modification and you paste to R2. Modification paste to R3. That way you'll be moving a bit faster. So to correct an error in an SEL, copy the SEL from the running config and paste it into the text editor. Make any changes, okay? Remove the previously configured SELs. Maybe if you don't want it, then copy paste and such. It depends with the kind of modification that you are doing. We have talked of the sequence numbers, which we did not add, but are being added automatically. Okay, because of the type of Cisco IOS that you have. So you can see here, IP access list standard. Okay, so you can see what we have. Okay, here 10, you can see 20, and maybe perhaps there's something that you see here, no 10. Okay, so 10, remember, was permit. Was it permit or deny? Okay, whichever the case. Then you want now to deny, no 10. Okay, then you want to modify that command, which is permit. Then you're saying now, this time around, deny 10 deny, okay, host this. So we're trying to block that host. We're trying to block that host there using the sequence numbers that have been automatically created for you. Okay, you can see, you can even, modify your own, those 10, 20, 30, but I want 15. I want 15. Okay, so 15, now you can just say 15 deny, then this particular host. Okay, so you are creating your own using the sequence number there. So if you check on it, it will be added. It's part of what now you have as the output there. Now, we have the statistics of the SEL. Okay, remember, there are things that you're not able to see with your naked eyes. In terms of traffic. So based on the SEL that you had set, okay, let's say deny, let's say permit. So there's those matching which will be there. For me to be denied, it means there's something which has matched and have been locked out, or something which has been what? Matched, that is permitted and have been allowed in. So for you to be able to see all this, okay, so you can see here, show access list. So you'll be able to see that the deny entry has been matched 20 times and the permit has been matched 64 times. You see, because the traffic are flowing within the network. So how many times are you coming in? How many times are you getting out? Traffic are just flowing, packets are just moving. So you just count the number of, times you'll be allowed in there. Note that the implied deny any statement does not display any statistics. Okay. To track how many implicit deny packets have been matched, you must manually configure deny any. You see, in these configurations, by the way, you have just said permit, but you have not said deny. Permit this, deny this. Permit this, deny this. Something to note again, by the way, guys. For the case of standard and extended. Standard, you can talk of permit any, deny any. Okay, take note of that. Permit any, deny any. For the case of the what? For the case of standard SEL. But for the case of extended SEL, extended SEL knows both, it knows source and destination. Standard knows only what? Destination. There's no source. That's why we are talking of any, permit any, deny any. Because of that, extended, as we have said, knows both source and destination. So permit any, deny any, when configuring extended SEL. Extended SEL. Permit any, deny any. Take note of that. Okay. Okay, we have the command access class command. You have set a virtual terminal. So this is more of a remote. Okay, this is more of a remote. And you are setting the SEL. So it means now you can have some sort of control again here. So you need to create an SEL to identify which administrative host should be allowed remote access for remote access. So therefore, you must set the access command access class command there, okay, for the virtual lines that we have set. Okay, now let's look at this example. Let's look at this example. Of course, I want to believe this part you had created the username admin secret class already. Then IP access list standard. So these are a named standard, admin host. Okay. Remark, this SCL secures incoming virtual lines, virtual terminals line. Then permit, okay, this, okay, this host, deny any. So it means only one specific host, admin host, is the only host that can access or can do remote access. The rest of the devices, no. Deny any. Okay, deny any. So any other, no. Okay. Then you see, remember this one, huh? Especially when we were configuring SSH. It's the same thing. So I want to believe SSH already has been configured. Okay, you have your SSH already configured. So that means the only thing that you will add, is access class admin host in, because now that one now is more of an interface or a line. So you're just adding this command, access class admin host in. Okay, in are there. Okay, so when you verify that, so you'll find that your port is secured. Okay, so as we have said, the SSH. So from your device, you're doing a remote access. The match in the deny statement is due to the failed attempt to create SSH connection from a device or another network. Okay, so that's why you can see at this login success. Okay, because you see, you do a remote access using the admin host. But any other, you can see, any other attempts which were made also are there. Okay, deny, as you can see. Perhaps you had used another host to do the same access, and those traffic were denied 2 times, meaning there were 2 attempts that you had made there, and you were not successful. Okay, as I finalize with extended, you have again both, as you have said, extended. As you can see, you have numbered and named. Extended uses the word IP access list. Named extended. Then you have numbered extended access list. Okay, there. But now this one is more powerful than the standard, because this one you can base your configurations on address, both source and destination. Okay, based on protocols, that is, protocols that have been set. Is it IP? Is it TCP? Is it UDP? Is it ICMP? And the port numbers. Unlike the standard, which will only either deny the traffic or permit the traffic based on the what? IP addresses. That's why extended is more powerful, and usually it's the one that is being configured, not the standard. Standard will limit you. You cannot do other things are there. So when setting that access list 100 permit, okay, you can see the other protocols that also you can set up. ICMP, for pinging. Do you know there's some devices that if you try to ping, you don't get the reply? okay, based on what you have set. Access list 100 deny ICMP. So meaning I don't want anything or some devices to be pinged on my network. Because you see, by ping it means you are getting the details, the information there, more details as the hacker there. The IP protocols also can be set, TCP, UDP are some of those protocols that can be set. Something to note again with the what? With the extended SCL, it's ranging from 100, okay, all the way to 199. The other one is from 199. This is 100 to 199. So if you come across the SCL with 100 and above, it's an extended SCL that has been configured there. Okay. We have also said that with the extended, you can have protocols and ports, as you can see here. Domain DNS, okay, 53, FTP 21, FTP data 20, POP, the email protocols, 110, okay, etc. So those are things that actually we have there, the likes of telnet and www, you can see, okay. So you can base it on the port numbers and the protocols as well. For example, what you can see here, okay, this and this, how you can write this statement, okay, to configure an extended SCL 100 to filter HTTP traffic. The first entry uses www port number. The second entry, is 80. Both entry achieve the same results. So it's either use www or just have 80. Either of those can work. For the second one, you can see, okay, configure the port number is required when there is not a specific protocol name listed. So you can make use of port numbers. So this is SSH being set. This is 443, that is HTTPS being set. So access list 100 permit TCP any source, any destination equivalent port 22. Okay, any equivalent port 22 will be allowed. Okay, any. Okay, so this one now you are dealing with traffic, TCP traffic, UDP traffic. Permit TCP. Okay, that's why you'll find that through the IP address you're able to access. Okay, but you see now about the traffic within a given network cannot be allowed or is allowed, because now you are specific on the traffic only on a given IP, address. So if you look at this, for example, the SCL permits both HTTP and HTTPS traffic from that network, 192.168.10.0, okay, to go to any destinations as per what is listed here. So access list 110, okay, 110. Remember, these are a numbered extended SCL. Access list 110 permit now traffic, okay, traffic permit TCP. So it means all the hosts in this network, you can say, will be able to browse through, this protocol. So that's why you have already, remember it was any, but the first any has been taken up with this. So allow all the hosts in this network, okay, to what? To access any, destination. So it's source destinations through the traffic, www. So are you browsing? Okay. So you can be browsing now. That one is allowed. But the things maybe you cannot ping, because what is allowed is only traffic, or what is denied is only traffic are there. That's the point here. TCP, again, the same network, you have allowed this, traffic. The HTTP and HTTPS, all these are allowed. All these are allowed. So 80 and 443 or www, okay, is allowed are there. So for the case of the named extended SCL, IP access list extended, okay, you can see IP, the word IP, for the named extended, the word IP, the keyword IP, then access list extended, then with the access list number. Okay, sorry, access list name, which you can see it's no FTP access, meaning no FTP access allowed. Okay, no FTP access allowed. Yeah, as per the naming that you have given there. And now, so this one, if you check, if confirm, now you'll be able to see what they have done. Just if you want now to see, now this keyword established, the keyword established, very, very important, by the way, guys. Okay, very, very important. Why is this important? I'm expecting the response from the request which were made. Okay, so the keyword established will be confirming that you are receiving what you requested. PC1 from the server requested what? Okay, and the same reply coming back, not the replies that you did not request. That's why the keyword established is being used here. Very, very important. So that way you're trying to block any other device that can take advantage of the requests that are being sent from my network. Okay. So if you send, let's say if you request something, okay, so I'm specifically talking to Kevin, give me this. Okay. Then, instead of Kevin giving me whatever I requested, it's maybe Korir giving me, those responses from Korir are not what I requested. So to thwart that, the keyword established will be used so that it's only Kevin that can respond to my request, not any other person can respond to my request. So the response from Kevin is what will be accepted. Okay, so it's one way also of, doing what? Preventing the hackers within our network, so who can take the advantage of the requests that are being sent out are there. So that's what they're trying to use. So that keyword is very, very important for us there. Just to confirm everything that you have requested is what you are getting there. The keyword established. Okay. So that's marked the end of the SCL topic, guys. Now I've taken much of your time, but same thing, I'll not do the labs for this today. It's the first lab tomorrow, okay? We'll start with the lab for the SCL tomorrow. Okay, now to wind up the part of the SCL completely. Unless someone has a question or comment or something before releasing you guys. I can see it's 20 past. Okay. Anyway, we're still within the range of our time. 8 minutes remaining, so we cannot do anything with 8 minutes. So let's start that lab tomorrow. Okay, first thing. Okay, unless someone has a question, and then feel free to ask, or you can still post it in the group. Okay, guys, if there's none, you have asked there, or there's a question on the chat. Okay, all have seen it. Okay. You are streaming YouTube. Someone is asking, you know, with the YouTube traffic, are you not YouTube? Are you not browsing or something? Because I want to believe, you see, usually it's www YouTube or something. What of specific traffic? Let's say like YouTube, YouTube. Do you have the specific number for the YouTube? Okay, yeah, www, because you know the keyword is www. That's what you are looking at. That's the keyword you are looking at. But I think if you want to block a specific request, I know commands maybe might not serve that, but I know there are things that still you can do within, let's say, the server, like the proxy server, still you'll be able to do those additional things. Okay, within the proxy by actually specifying the URL. You can make use of the URL. You can deny some URL, like the one for the YouTube, or you can permit them. And still you can work them out. Maybe not in command formed, but now based on the maybe the GUI interfaces, would be able to configure that there. Mhm. Okay, if we don't have more questions, guys, let's call it a day, and let's meet tomorrow with the more sessions. Thank you so much for your time. Enjoy the rest of your evening. See you tomorrow.